It's Tell Me Why, and today's subject, weather. We could talk all day long about weather. Brett, you and I have talked all day long.
Yeah, pretty much.
We've got two meteorologists for you on this edition of Tell Me Why. KSN's chief meteorologist, the legendary Brett Scott, and me, Gary Bandy, used to be KSN's chief meteorologist. And so today we are going to answer questions from middle schoolers who really are interested about weather. And in the part of the country where we're shooting this, there is a lot of weather that we have to be aware of.
Yeah, that's very true. Anything from, of course, severe weather, tornadoes, flooding, heat, cold, and another consequence of cold, snow.
Exactly. And so we're going to hit some snow questions and a few other weather questions in the next few minutes. And I think we're ready for our first question. Are you ready?
Yeah, I'm ready.
Well, I think we're both ready. Let's hear it.
Hi, I'm Drew. I'm 9 years old, and my question is, how does snow form?
Drew wants to know one of the basic questions in winter meteorology, snow, and how does it form? Because you look outside in the summertime, and when precipitation is falling, you can see through it and it goes plop.
Yep.
That's not what happens with snow.
Exactly. Snow tends to accumulate. You can have different types of snow, and we have some graphics to help explain the formation of snow. So, kind of like cloud molecules and also basically water droplets and water molecules, similar process of formation with ice crystals that form snow. You start off with a dust particle, which these are called a condensation nuclei. Nucleus just means...
Say that again.
Yeah,
I love it when you talk meteorology.
Condensation nuclei. So all nucleus means is basically the center and what is the attractor of water vapor in terms of basically not just ice crystals, but also water droplets and their formation. So extremely cold water molecule freezes onto a dust particle.
So this is the dust particle.
Yes,
is
of
that
course.
right, Brett?
Yeah.
So obviously this is bigger. This would be more like a dust ball. But in real life, these things are itty tiny bitty, right? Okay, so we got your dust particle.
Right.
Then what happens?
So what also is occurring, it's a water molecule. So that means that it exists as water, but below freezing. We call that supercooled water, which is water that exists at a liquid state below freezing. And once it essentially is attracted to the dust particle, you start to get naturally a hexagonal shape. So
No, wait a minute. Why? Okay, number one, hexagonal. That means 6 sides?
yeah, we can count them right there.
One,
Yeah.
two, three. Okay. Why would that naturally occur?
So it's due to the composition of water molecules and
Okay.
also how basically ice crystals tend to form and how water freezes. It naturally forms a hexagonal shape.
All right.
And right there, because of their shape, water molecules tend to form a hexagon when they bond together. And so you have several of these basically ice crystals that have nuclei.
Dust particle, all of these dust particles, and they're all getting real friendly.
Yes, and they get even more friendly. More and more get together, freeze and bond, and you get hexagonal ice crystal forms. And this sets the stage for the formation of snow. You start out with ice crystals.
So at this point, I'm sorry, Brett,
No,
at
you're
this
okay.
point, are we still, is it visible? I mean, is it still so tiny you almost can't see it? Or are we
very, very small?
very close to actually seeing a pretty snowflake, not unlike that?
It should be getting close to visible because they're going to continue to grow, especially if they fall through a favorable environment. So for snow to actually fall, the entire vertical depth of your atmosphere has to be below freezing. So it starts off as that ice crystal, and it stays an ice crystal as it hits the surface of the Earth.
Because if it's below freezing, it's going to melt,
Yep.
and it might fall at least through that part of the atmosphere as rain.
Right.
So what you're saying here is everything from my toe to the top of my head, assuming that I can make my way all the way up to space,
Right.
has to be 32 degrees or below.
Exactly.
Or it's not snowing.
So when you get those nice snowflakes that form, you get what's called dendrites, which are the little arms and needles that jut out from the snowflake itself. Those are additional water molecules freezing onto the ends of the crystal, and the dendrites are basically arms start to form on the edges as freezing continues. And the reason no two snowflakes are the same is because as it descends, as every snowflake descends through the atmosphere, it will interact with different temperatures and different levels of moisture, and you will get different formation of these dendrites. So that's why no two snowflakes are the same. And you can get different crystal types. You have plates that form under negative 22 degrees Celsius, which is really, really cold, but they can form at warmer temperatures. Needles, solid prisms, and dendrites are the ones that accumulate the best.
Okay.
So
let me ask you this. Say there's snow out there and I really want to build a snowman. Which one of these guys is going to make me more snowman friendly?
that would be the dendrite.
That's your dendrites, okay? Does that mean they're maybe a little bit warmer than the rest of them and they're maybe compactable?
So it's going to be very dependent on what you call the dendritic growth zone, which is where the dendrites are going to form in the atmosphere. It has to be very specific temperatures of negative 10 to negative 20 degrees Celsius.
Right there.
And that would basically set the stage for the best type of formation. And as they descend, they will continue to likely grow. But of course, when it comes to wet and dry snows, which is going to determine whether you're going to go snowboarding or build a snowman, that's a different case.
Okay, all right. This is complicated,
Yeah,
isn't it?
yeah.
This is why, and I've always said this, winter precipitation is the hardest thing for a meteorologist to predict.
Yes.
Because it all depends on the temperature, as we discussed earlier, as Brett said earlier, of the atmosphere at various levels of the atmosphere. So all of these things are possibilities that you have to look at when you're putting the forecast together in the middle of winter.
Yes. And so ice crystals tend to be plates, columns in air temperatures colder than about negative 8 degrees Fahrenheit, so very, very cold. And you'll usually get those types where you have those columns and plates. Now, dendrites are different. Your atmosphere is generally a bit warmer, or relatively warmer, but still below freezing. And you usually have branches or air temperatures from near negative 8 to 32 degrees.
And that's when you can pack them all up and try to throw them.
Yep, the closer it is to 32, the better packing. Yeah.
Like if we're walking in and the producer of this show happens to be walking by
Right.
the day that dendrite snow is falling, you can put a big old snowball together and just, she's standing right over there. Just, not that you would do that, I would.
Yeah. So yeah, that's pretty much what goes
That's
into the formation of snowflakes.
It's complicated.
It is.
Whew, it almost makes my brain explode a little bit. So maybe a little bit easier question now should be our next question.
Hi, my name is Presley and I'm 10 years old, and my question is, why is snow white?
Presley, that's an excellent question, and it's not an easy question to answer. We had to kind of do a little bit of meteorological research to find this out, because when you think snow, you just think white, right? Well, why? Why is that white?
So it's because of the ice crystals that make up snow. Think about how clouds are white and why clouds are white. It has to do with a process called scattering, which is sunlight coming into visible light coming into the atmosphere. And if we're looking at basically from the standpoint of the snow, why the snow is white, this light basically interacts with the ice crystals within the snowflake and is then scattered completely. So all colors within that visible light spectrum are scattered, so it appears white.
And really what you're talking about with these ice crystals is they're prisms. They are essentially the same thing as prisms, where they will, is that not true?
Somewhat. It's more of on the standpoint that they are scattered. That means that the light interacts with the ice crystal in a particle, and then all the light is essentially scattered away from it.
So
and
it's
all it
not
leaves is
that
white.
neat little rainbow of
Yeah, it's
that
not
you
the
would see
Pink
with a
Floyd
prism.
album cover.
It's
Yeah.
not, exactly. So that's very interesting. So that's why it's white. Is that why a lot of other meteorological things are white as well? It all depends on the light being scattered?
So the same thing happens with clouds, and why clouds are white, it is because cloud particles are larger than the visible light, and so it is all completely scattered. All of the visible light is scattered, so it appears white. Now, the reason the sky is blue is because of a process called Rayleigh scattering.
Raleigh.
Yeah, which the light comes in, but air molecules are smaller than the light that's coming in, and it essentially skews it more blue.
Okay. Now you said the first one, and I know, and we're almost finished with this. You said the first one was called me scatter.
M-I-E.
M-I-E. Does that come from the guy who discovered this?
I don't remember.
Well, I'm going to say it's because of Brett, because he says it's me scattering, and he is me because he said that when he was talking.
I believe that's plagiarism.
I think plagiarism, don't do that at home.
Yeah.
Kids. All right, we got 2 down, we've got more questions to go, and we still have some time. So what's our next question?
Hi, my name is Kane. I'm 10 years old, and my question is, why does snow fall?
Why does snow fall? An excellent question, because you would think that something that's in the air might just sort of float in the air, but it doesn't. Why does snow fall?
It does float for a good
There's
portion.
some floatage.
Yeah. Mhm.
Okay.
Right, because of winds. Winds will act to actually blow the snow around and keep it up, but generally it has to do with gravity, okay, because the snow at some point becomes more dense than the air around it, and it will begin to descend, and then it reaches the ground and starts to accumulate.
So if there's a little bitty tiny snowflake, and this is true as well when you're talking about thunderstorms, is it possible that those little tiny snowflakes aren't heavy enough to fall and they can get lifted somewhat? Does that ever happen? Because in actuality, when you're talking about a thunderstorm, that's sometimes that is how hail forms.
Right.
Because they get in this cycle of small pieces that get up and get encrusted with more
Right.
and more water, and they turn into larger pieces. Similar thing there. Can snowfall lift?
Yeah, so it's generally based upon the winds and also the updrafts of whatever the system that is keeping the snow going.
So
However,
there are updrafts in winter weather as well.
they are a bit more subtle because
Okay.
clouds that form snow are generally very shallow. You can get deeper clouds, which are more vertical, kind of like a thunderstorm. That's where you get the potential for thunder snow, but you also get heavier snow because of that. But you can have snow continue to be suspended in the air, but the thing about a lot of snow formation is that the forcing is usually the driving mechanism, and you do have some level of updraft going on because you need ascent
Right.
to help to form these basically mechanisms that result in snow. But once they form aloft, they will usually begin to descend.
Okay, so you used a very, very meteorological word there that I want to make sure everybody understands, and that is ascent.
Yes.
Ascent is something that if there wasn't ascent in the atmosphere, it would be a whole lot easier to be a meteorologist.
Yep, because nothing would happen.
Exactly. So explain in layman's terms what ascent means.
Rising motion, that's all it means.
And so rain or moisture ends up rising, or air rises to its level of condensation.
Yep.
That ascent is what turns into rain, storms, all of that stuff, snow.
Yep.
So ascent is a big deal.
Yeah, yes, of course it is. It is generally a driving force behind the formation of not just snow and ice crystals, but also rain and thunderstorms.
You know what I love about this show? People watching this show, every time they watch you do the weather at night, they're going to go, I know exactly what he's talking about. He's talking about ascent. He mentioned that on Tell Me Why. All right, we've got time for more questions. Bring them on. I think we're on a roll, Brett.
Hi, I'm Elise. I'm 9 years old, and my question is, why does the temperature change so much in Missouri?
Well, there's a question every single meteorologist or weather person on the planet, not just Missouri, has been asked. So Elise wants to know, why does the temperature vary so much in Missouri?
All right, so first we got to start off with the fact that Missouri is in the mid-latitudes of the Earth.
Whew, you're really getting wide out there.
Yep.
So, all right. What
So,
does that mean?
Yeah, latitude, okay? So think of the equator and then the North Pole. Now between those two is us. We are at the mid-latitude, so we're close to halfway between the equator and to the North Pole. And because of that, you have these large circulations within the atmosphere that transport warm air from the equator. They go up and then they go northward to the poles, they cool, they descend, they come back. Now, there's many of these what are called cells, and when they meet, you get the jet stream. And one of those jet streams is called the polar jet stream that we see quite a bit throughout the year. This feature, basically, you can have what's called troughs and low pressure within the jet stream, and it means it will dip further south, and that's usually where we are. It'll dip into our area, and what it does is it introduces cold air through cold fronts, which are a consequence of these large-scale features, because these large-scale features develop low pressure at the surface. You also get stronger gradients in temperature, which is a difference between hot and cold air. There you get a front, and a cold front will sweep through and it will cool us down rather rapidly. But as that system passes, then we'll have the potential of seeing a 180 change, and then you go from one day 40-degree highs, next day 70-degree highs, because there's no such thing as half measures in the 4 states.
That's very true. And when you talk about the jet stream, you're talking about some very fast air that is happening way up there, almost to outer space,
Right.
not quite to outer space. So why does something that happens so far up above us affect us so much when we are walking around here on the surface?
So remember when we talked about how tornadoes form in the plains? It's a similar situation because you have these large-scale waves go over the Rocky Mountains, and as that occurs, low pressure develops at the surface as it moves into the plains. What this does, it also reinforces that gradient between hot and cold air, and you get a frontal boundary. And as that front moves through, and especially in this time of year, and even in the springtime, it can usher in some cooler temperatures behind it. Sometimes fronts don't do that. And sometimes you have boundaries that usher in much drier air into an area that has better moisture. And usually you see those in the Great Plains. Those are called dry lines.
And that too, all of these things, when Brett's talking about fronts, all of these things can force, and we talked about this earlier, ascent, which turns into weather, which turns into rain or storms or any of these things. You know, I was a meteorologist when we started this show. I'm a smarter meteorologist now just by hanging around Brett. Brett, thank you very much.
Of course.
I think we answered some great questions. We love doing this on Tell Me Why. We have many more to choose from, so just check them out on the menu. That's it for this Tell Me Why, though. We'll see you next time.